Hello, I am Eric Miskell. I'm the publisher at EMS2, and thank you for joining us today for the third episode of our webinar series, EMS 2.0, How the Electronics Manufacturing Industry is Evolving. In this episode, we will continue to explore the evolving production requirements for electronics manufacturing as we move towards the factory of the future. The COVID pandemic has certainly been an accelerator of many trends, and automation and digitalization are two such major trends that have directly impacted the EMS industry. We will be speaking today with two leading companies engaged in this work. I do wish to thank Bright Machines for sponsoring this series and allowing us to have these conversations. Our guests today are Mike Geraci, the Chief Digital and Technology Officer with Molex, and Brian Matthews, the Chief Technology Officer with Bright Machines. Gentlemen, thank you both for your participation today.
Thanks, Eric.
I always like to start by allowing you to introduce yourself for the benefit of the audience, both yourself and your company, if you would. And Mike, why don't we start with you on that today?
Great. Well, thanks so much, Eric. It's great to be here. And I appreciate having the opportunity to share a little bit about what's happening at Molex and our perspective on what's happening on the broader industry. I joined Molex a little over a year ago in the role that you mentioned. My primary focus is helping us drive our transformation in terms of understanding how to deliver a better customer experience through the context of digital enablement and really enabling our employees to have the capabilities they need to ultimately fulfill against the promises and commitments that we are making to our customers. Prior to joining Molex, I worked in the hospitality and retail industry. So this is a little bit different, in terms of understanding what's key to helping create value in this segment. But I feel like bringing that perspective in terms of how to enable the delivery of the products and services in a way that helps our customers move faster, ultimately achieve greater outcomes with their end customers or consumers, and just understand, quite frankly, what we need to be doing, across our enterprise. Molex is a global company. We're roughly $6 billion in size. We operate around the world, providing connectors, cables, and components to various end customers, and we're also in Industry 4.0 products and services. So we have a couple different operating models that we're evolving. And it's an exciting time to be there. And I appreciate the opportunity to chat about it.
Excellent. Thank you for that. Brian, if you would, please.
Sure. I'm Brian Matthews. I'm the CTO, Chief Technology Officer at Bright Machines. And we formed Bright Machines really with this idea of having a better way to do manufacturing production. We focus on, right now, starting out with a focus on assembly and inspection. You think of automation, and automation isn't new. It's been in the industry for decades, but there are large parts of production that are not yet automated. And, my background was educated as an electrical engineer, worked in the software industry, serving the manufacturing industry with CAD software, CAM software, simulation software, and more. So have that kind of background on how do you take technology and improve this industry. And the funny thing is while we were trying to support manufacturing, there was a huge revolution happening in the software industry. It kind of culminated with, cloud computing. And if you think of the cloud, the way I like to think of it, the cloud is just another form of manufacturing. You've got a lot of different types of equipment, everything from air chillers to, power distribution, networking gear, all this stuff. These are like production machines. Mm-hmm. And you need to automate various tasks. And the funny thing is the software industry learned a tremendous amount from the manufacturing industry. This is where concepts of lean and just in time, agile, all these are manufacturing concepts. But being in the software industry and running very large cloud operations, it kind of dawned on us that the software industry kind of took these ideas and went further. And so we founded Bright Machines with this idea that there's a better way to do manufacturing using these concepts of using software to control automation. We call that software-defined manufacturing. And it mirrors software-defined networking, software-defined infrastructure, software-defined computing, all of these other software-defined, everything. How do we bring these concepts back into manufacturing? And that was really the start of Bright Machines. And so we're kind of a full stack company that has hardware and software. We're really a software first approach to automating final assembly and test on production lines.
Excellent. Excellent. No, and that we'll get into that and I think that's a good way to characterize as we launch here. But let me ask first about, we've all lived through a challenging year here with COVID. And so I'd like to kind of get a sense, as I often do, for kind of what's your experience been for your company. So maybe Mike, if we start with you, kind of what's been the impact of COVID-19 on your operations, and what lessons have you and your business learned in the process?
Sure. Well, I mean, I think, first and foremost, just ensuring that everyone was safe and healthy was a critical outcome. And we were very focused on that. We have physical locations in China and in Wuhan. So we were dealing with this fairly early on when it started to present itself. And we had to fall into a pretty quick business continuity process because our locations in China were directly impacted. So learning how to work remotely was something that, although we had the capability to do it, it wasn't something that we did normally. We were kind of, everyone needs to be in the office type culture, which I think there's real value in for sure. But I think we learned as a culture that we can actually be in many different places and be pretty effective. I think decision rights and how quickly we needed to make certain decisions, there was further analysis on that because we just didn't have the time, quite frankly, to come together and meet in person like we normally would. And I also think our transformation program was severely challenged. I mean, we're in the process of evolving really our commercial architecture, everything from innovation through fulfillment to the end customer. And given that so much of the infrastructure was in Asia, trying to develop and drive programs like that in such a disparate time zone, working remotely, really challenged the team. Our team stepped up and had a really strong year from an operational perspective. We kept all the things working that were supposed to be working, but I think the organization, particularly leadership, really has a new perspective on how do we geographically connect and how do we ultimately drive value to the customer. And I think our customer changed also. I think that they also learned that there's ways to do things that maybe weren't considered so traditional or acceptable in the past. So the marketplace is faster, and the marketplace is only going to get faster. So our ability to execute internally and really adopt some more of those digital ways of working, if you will, as was Brian was mentioning, is critical. I mean, we just can't continue to operate the way we did pre-pandemic. So, our perspective is that this is just the new way. It's the new norm. We need to be ready to take advantage where we can and focus on making sure that our teams have the right functionality, have the capabilities they need to make a decision in real time and impact performance in a time frame that actually matters.
Okay, very good. Brian, what's your experience been?
Well, yeah, I hope we have a follow-up question to talk about our customers' experience. I think very similar. Our experience, we were founded as a global company, and as a global company, when this change happened, we were already kind of software first, software centric, and global, meaning we already had to have solutions to many of these problems of being in person. We couldn't previously. So, certainly there was an impact. If you think our sales process, there was a huge impact there initially because sales was always such a customer touch thing. You fly around, you meet customers, and you bring customers into your factories. You want to show them how previous automation projects have done. That's really important to customers. So, one big change in our operations was going to virtual selling. And, at first we thought it was, kind of a gimmick or something. And then after doing a couple of them and figuring out how to do them well and how to really get at the customer's questions and really demonstrate in a factory with a setup. You know, we have a rolling caster system with cameras and laptops and everything, and microphones, you know, wireless, and so it's like being there. And we take people on factory tours. We show them automation solutions. They ask questions. We open things up, take it apart, and so on. So in a way, the impact was dramatic but short-lived, and we adjusted very quickly because, you know, like I said, being global and software centric, it's kind of normal operations.
Yeah, no, it sounds like that. And it's funny you say that because I've heard from some EMS who did factory tours, those virtual ones with a cell phone or an iPad, kind of walking through their factories, showing it off to prospective clients during.
Yeah, and where a sales team or a engineering team, you know, might have been able to do one or two customers a week or three customers a week, now they can do three in a day.
Exactly. No, it's everything's moving faster there. So.
I mean, Eric, it's an interesting point that Brian raises, you know, the sales and relationship process. And we've
Mhm.
also experienced similar type of activity where we've been able to reach out and digitally provide and help people think through innovation in that manner. The other aspect of it is just deploying capabilities. We've had to deploy technology remotely, where in the past you would send, you know, a team of people to a location and they would kind of converge on that location. And that's how we would drive the adoption of whatever technology it may be. And obviously you can't do that right now, not as effectively as you'd like. So the teams had to learn how to trust processes that they would not have trusted in the past. And I think it's been really good because it's elevated, thinking around, we don't necessarily have to be physically someplace to have a really meaningful impact on the outcome. And in fact, we might be able to do it faster. We can make a decision faster. But I think that our technology team would have been hard pressed to think that they could put an automation program into a factory plant remotely in the past. And now it's kind of expected that we need to be able to do that. In fact, we have to be able to do it.
Yeah. Yeah, and you used an interesting term there, trust, right? I mean, we had the ability to do this last year, right? It's just it wasn't the impetus to do it, and maybe this process, unfortunate pandemic, gave people the trust in those processes, and because it was forced on them, and now they know. And like you say, it's the new norm moving forward.
Well, I think for software companies like Brian, it's just how we work. So what's the big
Yeah.
deal? For hard product manufacturers, it's a little bit different.
Absolutely.
Yeah.
And so
Yeah, and I think the impact on the customers has been a little more dramatic. I mean, we should definitely talk about that. But even in these automation solutions, yeah, for a software company, it is the way you normally work. But being a hybrid company where we have hardware as well, one of the things is that we're, again, trying to bring these software concepts into the hardware. So what are the built-in diagnostics? Are there built-in diagnostics cameras that are in there? Do you have remote management tools, remote diagnostic tools, remote logging tools, and so on? Get you into this industry 4.0, which was all about production. But really, if you extend those concepts, it can really be about how do you deploy, how do you manage, how do you debug, how do you deal with problems, and you can build these kind of software management concepts right into the system. What is the equivalent of GitHub for manufacturing? What is the equivalent of ServiceNow for manufacturing, and so on? And these are companies and ideas that started in hardware, went into the software industry and went much further, and we're trying to bring them back.
Interesting. Well, Mike, excuse me, Brian, you've mentioned it a few times, and it is a valid thing. Talk about the customers during this time. I mean, we all have a variety of different ones, and I'm sure the experience has been somewhat varied, but what have you been seeing?
Well, at first, I think, customers were pretty affected because it's uncertainty. So if you are in manufacturing, you've got a lot of materials, you've got a lot of equipment, there's a lot of dollars, capital inventory on the line. And if you don't know if your customers are going to be buying or not, or where they're going to be buying and what they're going to be buying, it's really the uncertainty can just delay decisions. And so that was, I think, the first effect that we saw in the first couple months was, I really want to do this, but I have so much uncertainty, I'm kind of paralyzed. I think the next thing that happened was a realization. There's this realization that the problem that COVID brings is really a labor problem. And one of the ways to solve a labor problem, of course, is automation. And so that, of course, started a very obvious conversation. But if you zoom out a little bit, I think the other thing people realized was this wasn't really about COVID at all. That if you go back a year ago, I think there was, I saw a survey, less than 10% of Fortune 500 companies really had on their risk mitigation plans anything about a pandemic or this kind of thing, supply chain disruption and so on. And now it isn't a risk, it's the risk, right? But if you zoom out, look at what we were dealing with right before COVID. We had trade wars and tariffs going on, right? You had labor issues even before COVID, because I know in a lot of parts of Asia, there's about 300,000 people that are going to quit their jobs this month in the electronics industry. What globalization did is it raised the standard of living for people worldwide, and they have other options now. And so it's hard to find cheap and plentiful labor anywhere. Labor was a problem, tariffs were a problem, and now you throw in a pandemic and supply chain. And the answer isn't just automation for labor. What it really does is it allows you to localize your manufacturing. Before you had to offshore in order to be competitive, but with automation, you can bring manufacturing where the market is. Even in high cost areas like Germany or the United States, we're seeing them able to do production in high cost countries because you can offset those labor costs.
Gotcha. Mike, anything to add on the customer side before we?
Well, I think Brian brings up some excellent points. I guess if I was to add anything, we also saw a very similar reaction to the initial onset of the pandemic, but we have a pretty diversified business, and we had a couple markets that, quite frankly, exceeded all possible forecasts, prior to the year, based on demand and need. And the demand was really driven by people changing how they worked, particularly in the data center and technology sector. So, where we had, challenge in some areas, we had expansion in others. And I think from a customer perspective, they had to learn how to react to that, unforeseen demand and almost limitless in some aspects. And I think that, our ability to collaborate and innovate quickly is going to be really important going forward. We have to be able to stay close enough to their end customer. We talk about B2B relationships and we act like, well, it's a business to business, so the same rules don't apply. But the folks in the business are basically customers, they're consumers. You're a consumer just like Brian is, and you have certain expectations and you have a certain way you'd like to engage around a product and a service. I think that COVID-19 really accelerated that from a business perspective in terms of expectations of how you're going to service a customer and what they're expecting out of that relationship. And I think that's going to continue to evolve and accelerate even faster.
Okay. Yeah. I mean, there's some data out there in the market. Thomas Insights, there was an article, they were saying they're seeing demand for automation solutions go up 150% this year alone. So yeah, there was a hit at first, and now we're seeing just the opposite. And the word we use, in the software industry is resiliency. When you run a data center with 1 million machines in it, if you're running hundreds of machines, you want really resilient equipment, redundant hard drives, redundant power supply, redundant this, redundant that, right? And you spend a lot of extra money to get that redundancy so that you reduce your risk. But when someone like Google and you have, tens of millions of machines, no amount of redundancy is going to have all the equipment working properly. So the software industry has changed their thinking from redundancy to resiliency, which is accept failure and plan for it and build it into the system. And that's why I think when we get into manufacturing, how do we bring a resiliency concept into manufacturing? It's really not doing automation the way we've done it in the past. The past automation has been bring in a bunch of system integrators at high cost, take the specific product I'm trying to build and integrate a bunch of conveyor systems and robots and this and that, and get this one-off thing to make 1 million of something. Well, that's not a very resilient solution at the end, because what you've really done is you've automated the making of 1 million products, but what you've done is a highly manual process of coming up with the automation. And so I think the big aha here is, like the software industry in a big data center, they don't do anything manually when you have 10 million computers to manage. And what you really want to do is come up with the automation tools that help you produce automation. And that's really what we've been trying to do, is use software to automate the process of automation, and then it becomes reusable. So once you've come up with a modular building block of something, you can reuse it on all future projects. You can scale up, scale down, move production. And it's not that old type of automation, which was very manual, hands-on, custom for that one product, and doesn't allow you to move location, doesn't allow you to make a change to the product. It's a different type of automation that we're talking about.
Mhm. That's very good. Well, let's get into the shop floor, the electronics manufacturing specifically, and let's maybe start by getting your opinion of on the evolution of electronics manufacturing and how smart manufacturing is bringing about a shift on the factory floor. And Mike, maybe start with you on that, if you would, sir.
Well, yeah, I think, as I mentioned earlier, we're investigating this both from an internal capability and also commercial product perspective. And what we're focused on is, how can Molex apply our comparative advantage in a way where we can enable, think about platforms versus, kind of solutions, if you will. So the example Brian just gave around resiliency and so forth, we think that there's opportunity within our organization to certainly connect things way more intelligently, whether that's physical hardware, machine devices, manufacturing location, whatever it may be. There's just, we haven't been able to connect our shop floor up to our customer experience yet. And that's what we're highly focused on. So how do we make sure that by using new capabilities, new trends, if you will, we can deploy those technologies so that when our customer wants to design something with us, we have the ability to bring it right into our manufacturing cycle? How do we cut out weeks and weeks of time, cycles and cycles that have disabled us from performing faster and quite frankly, more efficiently? Because ultimately, what our customer wants to reward us for is how we create value in their value chain. So our perspective is, what really matters across that activity? Where do we need to be highly capable? So it's in supply chain. It's making sure that we're making the right decisions on the raw material and products that we need to have access to. It's understanding demand more effectively and moving demand from kind of reactive to much more predictive and proactive. Kind of getting into collaborative planning in a way. And on the innovation piece, it's when we innovate something, let's not innovate in a way where we have to then reformat and retransfer into something else. How do we ingest that into our process from a manufacturing sample capability and get something out very quickly so the customer can actually touch something? And when we think about that, it's really about our commercialization process, and it's making sure that we're connecting that in a way that helps our customer earn more value. I think across our broader organization, the concept of what I would say, highly intelligent sensory capability. So a little bit to Brian's point around automating the manufacturing process. Where do we have impact on the performance of driving more value in that manufacturing process? Can we automate? Can we innovate in a way that helps us improve, fairly dramatically the output of that process, whatever it may be, and then scale that across the enterprise? So Molex being part of a broader organization like Coke, and then there's a lot of opportunity to apply that IoT of everything, if you will, across those manufacturing plant floors. And then through that process, how do we learn from that and then take that out from a commercially viable product? So there's a lot of activity in that space. And Molex, having grown up as a hardware company, adopting a software life cycle, software product mentality is a big cultural change. So there's a lot of work that we're doing in terms of learning how to be if you will. We've always had software, but actually having software first products is a little bit different. So it's been interesting.
Yeah. Brian, what's your view on this?
Well, again, I think I agree with all that. And I would just add to that, it's about the workflow. If you think in the past, some of these concepts really aren't new. Industry 4.0 has been around a while, and there's technology companies that have been trying to solve individual parts of this. But really, how you put it all together, I think, is interesting. So, if you think of it of a workflow, how often is a design done by a designer in a CAD system with no knowledge of how production actually works, right? You design it, you bid it out there, and somebody wins the bid, or you throw it over the wall to some other department and say, make this. And so, we've had things like digital twin that could potentially improve this. We've had, the ability to simulate and so on. But it hasn't ever really been integrated in a really practical way. And I would also say, if you go, let's say in the electronics manufacturing industry, the front of the line's already highly, highly automated. You've got, SMT machines, pick and place machines that are highly automated already. There is no problem there. So why is there a problem at the back of the line with the assembly and inspection? And it really is a lack of standardization of the product, right? Every circuit board behaves like every other circuit board, so you can use the same equipment, the same programming tool, the same workflow. But when you get to final assembly, that's no longer true. You need custom grippers, custom this, custom that.
Yeah.
And the digital twins have been around. The problem is that in the past, what it would require to model the reality is so expensive and so slow that it's sometimes faster to just do it in the real world. Because you need a company that can take data straight out of CAD, that can bring it into simulation. And if you have your automation solution that's made more modular, in a modular Lego brick kind of way with reusable components, where you get rid of the system integrator who's doing everything custom, nothing reusable, means that simulating it becomes that much more expensive and slow. Bringing the CAD data into it becomes that more expensive and slow. So really, I think you have to look at a workflow picture. And I think this is the mistake of many customers when they look at traditional automation. Whatever process you have, you look at all the different tasks you have, and you can automate it all. It's just a question of how expensive and how slow it is, right? And so you automate things like the front of the line that are relatively cheap and relatively quick to deploy, and things that are expensive and slow compared to labor, you don't. And you just look at the cost benefit curve, and when they intersect is where you stop. And I think that's a mistake, because you're not looking at reuse. You're not looking at continuous improvement. You're not looking at the ability to continually innovate your product. And we're seeing this trend where the run length of the average product is shrinking, where people want to make changes and they don't want to reduce quality when they make the changes. They want to keep that same quality. So, it's kind of a long-winded answer, but I think you have to take a holistic approach to everything, from how you design to how you simulate to how you deploy, and then how you capture that data. And it does leverage Industry 4.0 concepts, but it's taken it at a different level. Industry 4.0 is always focused on this one product, this one task. And I think you really want to broaden that to think about what is your entire operation. And you don't have to deploy it all or nothing like that. You can do it incrementally, but you have to think holistically as you're taking those baby steps.
I mean, I completely agree with that, Brian and Eric. I mean, this concept of an ecosystem that's really operating for the benefit of value creation in terms of whatever that outcome is supposed to be, and connecting that, it's just not the way manufacturing, or quite frankly, most companies have grown up. They just haven't thought about the horizontal intersection on the key activities that ultimately create the outcome that's been requested or is desired, or that needs to keep iterating so it gets better. And the focus of our transformation is really that. There's certain things that really matter in our industry that our customer is willing to reward us for. Those are the things that we have to be extremely capable at. there's other things that, just need to happen. And, to Brian's point, they're pretty inexpensive and you can automate them and you just like move on. But if you try to fix everything, there's no possible way you're going to be successful. And I think being able to focus, where you want to impact is hard to do sometimes. I think it's very, particularly across a leadership team, that manufacturing companies normally have longer, decades of culture, decades of working. Things have worked a certain way, value's been created a certain way, and changing that in a digital economy, for lack of a better description, is a good challenge. So manufacturing, I love Brian's example of, you can localize it, right? You can hyper localize it with automation. You can actually put it right next to where demand is. But if your mental model is that, well, no, that's not how we do it, because we have to have these following things, then you're never going to connect an ecosystem. You're just going to be connecting parts of a solution to many aspects of a problem.
When we spoke before, the three of us, the term that I captured from that was, I think, forget which one of you brought it up, but I think you both agreed, was the idea that factories have become are essentially large data centers, right? And I hear you talking, Brian, about the various challenges within the electronics manufacturing, but how does that help or complicate the process then? Because now we're generating more data than probably ever out of these factory floors, right? And we have the tools and equipment that are adjusting to that. Does that make it more challenging? Is it just a process we need to work our way through?
Yeah, I mean, there's a couple things. I've got to try and keep all of my thoughts and not drop some of them, because there's a couple of points you're touching on there. I mean, one thing I'll start with, and maybe I'll hand it off to Mike while I organize some other thoughts, is, a lot of people go into Industry 4.0 on the IoT side, and I'm just going to capture a lot of data and I'm going to get magic from all that data. So I'm going to hook it up to a machine learning, but I don't actually know what problem I'm trying to solve. I see that often instead of zooming out. But I think there's one question to ask is, why hasn't this, assembly and test, why hasn't everything been automated? Robots have been around since the 70s, right? So what is the thing that's holding everything back? And I don't think it is one thing, but there has been some stuff that's changed recently. So as I mentioned before, a pick and place machine is already highly automated. The solder printer, already highly automated. There's a lot of stuff that's automated. So when things are standardized and there's no variation, that's great. And humans are great at variation. So I think the technology that has changed, if you think of robotics, they're blind, they're numb, and they're dumb. And, they're also alone. And if you look at what has happened in the software industry now, let's take blind, for example. Computer vision has gone through more innovation in the last, 2 years than in the last 20. And I don't think this industry is really got the kind of experts that you find in other industries. Like the self-driving car industry has sucked up every computer vision expert in the world, except for my company, because I hired a bunch of these people out of there. So that technology innovation is not being brought to bear, and is one of the reasons why humans are so much better, why you can do robotics for pick and place, but you can't do for final assembly, I think, is computer vision, right? So making robots that can see. The second thing is they're numb, right? And there's all sorts of new force feedback systems out there that give tactile and infrared and ultraviolet and all sorts of different types of sensing. That's a vibration, sound, RF, you name it, right? Sensors have become cheap, and we have the way to integrate that. So blind, numb, and then dumb, right? Well, obviously machine learning has made tremendous gains recently. So if we integrate those three, so those technologies just exist. There's toolkits, there's platforms, the stuff's out there. It just hasn't been integrated for this industry. And I think that's what we're trying to do. And the last one I put there is, and that they're alone. That's kind of one other problem with labor. I think when people don't look at an ecosystem, they look at product X. I'm going to build this pen, right? And I can figure out all of my process, and I can train my people. if they can be near each other, in a COVID world. Um, but if I want to expand production in another region, another location, I have all the hiring and training and all that stuff. The neat thing about automation is once you train one system, you've trained them all, right? And that hasn't been true traditionally in robotics, because traditional automation with those system integrators and custom solutions, if you spin up one line with a robot doing some process, if you try and do that in another country, copy exact, you can't copy exact. And the reason why is the screwdriver bit in robot A was this long, but in the other country, the screwdriver bit is 1 millimeter longer, and the conveyor belt is 1 millimeter away from where it was in the previous one. Everything's different, even when you have these custom solutions. And again, that's where computer vision, that's where machine learning all come into play. And this is where that promise of a digital twin and cloud simulation and all that stuff, the reason why they never took off was because the simulation never matched reality. You could do all this offline programming, you could do all this what if analysis, just like in a spreadsheet. But then when you tried to actually deploy it to the real world, you had to do all the work over again because the reality didn't match up to anything. And computer vision and machine learning change all of that. And now I think you're going to see a real revolution here.
Interesting. Mike, what do you have to add to that?
I mean, I think that's right. I mean, I would complement that with this concept of that aspect of data, and that the data is actually the asset. But if you're not looking at it from an integrated fashion, in other words, many companies grew up with this ERP mentality, and I had to process transactions, so I need certain sets of data to process transactions, and I want to automate those transactions because I can do it at scale and I can repeat them. But the reality is, when you think about manufacturing and developing something, there's multiple dimensions of data that you need to be thinking about as you're going through that process. And can you process it fast enough so you're making the right decision to get the appropriate outcome? Data and data services and enabling data, data lineage, if you will, changes a lot of that. And I think in the past, a lot of those services didn't exist, or if they did exist, it was not well understood. I think from a technology perspective, layering digital with data into the manufacturing floor, if you will, and then driving at it from, I actually do need to see, I need to understand demand, but I also need to understand my sell-through, because I can monitor my schedule based on how I'm executing against that in fulfillment of whatever customer it may be. And by the way, this product that I'm making here, I can actually service multiple verticals with this product. With, to Brian's point, the adaptation of customization appropriately. It changes, right? You now have a platform which you can operate from. And I think that machine learning and AI is useless without really good data. It just can't do anything. So are you producing the right information? Is it relevant and available? And are you curating it in a way where it can be consumed and applied to something that you're trying to drive advancement against? And I think the companies that really understand that and do it well are the ones that are going to win, because they're going to operate faster than ones that can't.
Okay.
Yeah, and I think if you take all that, I totally agree with all that. And you apply COVID to everything that was just said there, I think the cloud becomes more important.
Yeah, absolutely.
If you're going to be hyper local, if you're going to be data driven, if you're going to be adaptive, if you're going to allow customization without reducing quality, you can't have the same system integrator approach. You can't have that same jig, fixturing that's, so rigid. You need flexibility built into the system. So, it has to be reusable modules, but you need flexibility. And if you're going to go on a global basis and monitor globally and debug a problem in a remote location, everything we're doing on Zoom of how we just run our business, you're going to have to be able to do that with your manufacturing the same way. And so, the net out of all of that is that the cloud has been something that people have kind of resisted the cloud in this industry for security reasons and a variety of reasons. And I think if you really want something more resilient, more flexible, and flexibility is a lot of what we're talking about here. I don't see how you can become more flexible and resilient without moving more towards the cloud.
Mm-hmm. Where is it then, the difference between the cloud versus on the edge there, right? And within the factory, how do you differentiate then which belongs where from the data perspective?
That's actually a funny, that's a good point. I didn't say edge, but in our designs, we have to build that in. One of the things, you learn real quick in this industry is nobody puts a factory in downtown San Francisco. You know, you usually find factories in places you wouldn't want a vacation, where land is cheap. And that often means the infrastructure isn't always the best. You can't rely on the internet in a factory. And so again, if the point is resiliency, you have to build resiliency into everything, including if you're a cloud-centric approach, assuming that the cloud isn't there. So edge computing is definitely what it's all about. But I think rather than just edge computing and doing some of your IoT work at the edge, if you really build this concept of resiliency to every level, then it's more like how your email works. You can get on an airplane with no internet, and you can work on your email, and you get back and you sync. So the system doesn't require internet, continuously, but it does require internet. Email without internet does not work, but it doesn't need to be on all the time.
Right.
And I think that's the direction that we've been designing into our system with edge computing. And I don't even like using that term. I call it the edge cache. And we're doing a lot of stuff locally, and it's all in how, again, you build this a modular. If you're going to have a database, you can, with these software technologies, you can package up databases so that you can deploy them anywhere. You can deploy them on a particular machine, an actual manufacturing cell. You can deploy them at the edge of the factory, on the line, in the building. You can deploy them in the cloud. And if you architect things, not just your hardware in reusable Lego-like building blocks, but if you make your software that same way, you write the code once, you write that business logic once, and you make it so that it can deploy anywhere. And that's what a platform really is. A platform that does that caching, that does that synchronization, that doesn't require the internet to be up and on all the time, but brings you all the benefits of when you need it, when you need to collaborate, when you need to run your centralized machine learning algorithm, not just on the parts being produced in China, but the ones that are being produced in Germany as well. And you want to bring all of that together into one machine learning hive that can take action with that. You want to be able to debug remotely. You want to connect in there.
Excellent.
Eric, I think that's spot on. And there's industries that had to adopt that way of working probably earlier than manufacturing did, just because of how they operate, whether it's retail storefronts or cruise ships. It can't be rendered incapable because it lost connectivity. Like, it just has to work. So the design of the software to ensure that resiliency is present and you can still run your operation regardless of the status of your connectivity is pretty critical. And I'm completely aligned on the architecture discussion that Brian just had. It's really, we call it edge, but it's just another layer of resiliency. And the technology does what we need it to do because it's capturing the information we need to make better decisions and perform more effectively. But the internet is not, it's not the critical aspect of that. It's the software architecture and how we ultimately service and provide the data.
Okay, thank you. No, that helps my understanding too. I appreciate that. So what then are some, you've, in our discussion about the hardware side of it, we've been talking about the term modularity has come up here, making that so that more plug and play and more modular. So what are some of the broader trends in automation that you're seeing then in electronics manufacturing? Maybe Mike, start with you on that.
Well, I think we've touched on a few of them here. I mean, certainly, IoT and sensory capability. I mean, I think having a more intelligent ecosystem is something that's happening, and leveraging AI and ML, advanced robotics. I think Brian did a great job of describing that. Robotic technology exists. Why are we not applying it more broadly, if you will? Like, what's preventing that? And I also think there's discussion on just like the ethics of all this, in terms of job creation and impact to, people, what jobs are the right jobs to automate, if you will, and which ones do we want to consider maybe we don't for various different reasons. I mean, there's a lot happening right now in terms of how you think about the architecture of the manufacturing floor, if you will. There's a lot of great technology, and these trends are all happening. We've been using RPA in different aspects of our business for quite some time. That's being applied to different levels of the manufacturing floor. But I think ultimately, I guess the best way I would describe it is, I see it as a very integrated digital ecosystem. And we're no longer thinking about the shop floor as different functions or different phases of something. It's fully integrated. It's a commercial capability that we have to connect to the external world. So how do we make sure our customer has the ability to connect to that, and we connect to the marketplace? Because if we can do that, we can deliver products faster, and we can deliver probably more efficiently than maybe other folks can, and that will be a differentiator for us. But the example that Brian used, that you're right, we're not going to build a manufacturing plant in New York City or Miami. It's a little too expensive to do that. However, we are going to have them in places that are inexpensive. But that being said, it can't feel like it's a remote disconnect from what we're servicing our customer. It has to be connected to, particularly when we're co-creating and developing new capabilities for them that they need to consume at a faster pace.
Interesting. Brian, what do you have to add to that?
Well, agree with all that. Maybe I'll take a different angle. You were asking about, hardware and all that. So, I think the analogy, a good analogy is, cell phone or SpaceX or things like that. It really is really basic, simple stuff. All cell phones got to have basic capabilities. You got to have the camera, you got to have the cell radio, the Wi-Fi, the this, that, and the other, and it is kind of a formula to it. And those parts can be reused and remixed and remashed in different combinations, to find out what the market wants. And I think, that it's really that simple for hardware. Conveying systems, robotic arms, power supplies, control systems, safety systems, all of that. And how do you make it so that it's under software control rather than requiring custom programming? Anytime what the effort you're doing, that time and energy and cost, is going into something that's only going to be used on this one project, that's where you're going wrong. And I think this is where the software industry, if you wanted to test a piece of software, you can have a human try clicking on a few buttons in a dialog box, and it's cheap if you're only going to do it once. And so if you only ship your product or make a change once every 3 years, then that's the way to do it. But what you see companies like Netflix and Facebook and Amazon, unlike Toyota, software companies are changing their product over 1,000 times a day in production. And if you made a change to a Toyota Camry 1,000 times a day, I think your quality would go down and your costs would go through the roof. What automated systems allow you to do is you overinvest in that ability to automate and test, and it actually becomes higher quality at lower cost. And that's the fallacy of that cost benefit reward curves, where people look at the current project in isolation and think of the cost of automation and the benefit for that project, and they don't think of the bigger scheme. That's what the software industry really figured out to flip. And I think this is where this market could do so.
Okay. Listen, I'm aware of the time here, and we could keep going, but I wanted to kind of wrap up with a couple of questions. And one of them is we've touched on this already, the concept of Industry 4.0. And like you said, it's not new, it's been around, right? So how important are the concepts such as Industry 4.0, and how would you rate the adoption of those by the electronics manufacturing industry? Mike?
Well, I mean, look, I want to be careful how I respond to this because it has, there's significant implications to what we're trying to do at Molex. We see one of the major opportunities in Industry 4.0 as this interconnection of the ecosystem. How do we take these different hardware or software providers that sit on the floor? How do we interconnect them? How do we help those individuals run that floor more effectively? How do we create better visibility to the lineage, if you will, of the process, and ultimately create capabilities that don't exist today? I mean, much like some of the the software integrators have done, if you will. When you think about a microservice capability or things of this nature, how do I enable this to be accessible to multiple parties faster and eliminate some of the translation activity that has to occur? I think for us, we're focused on the outcome. So where are the challenges that we have on the manufacturing process, whether it's across Coke or within Molex, and how can we solve that more effectively by adopting Industry 4.0 type technologies and capabilities and applying them to that, but not trying to solve all things, right? Not everything matters the same. So where are the bigger ticket items, if you will, that we think really would create value, and then go solve for that. And let's not create a solution looking for a problem. Let's take a problem and then have a solution and apply the solution to that. And as we learn our way through it, then how do we make it something that could possibly have an offering in the broader marketplace and commercially represent that? But without doubt, we've had a strong legacy of cable connector component capability. We've built a strong business on that. It's been a good business, and it still is a great business. But I think going forward, this concept of integrated ecosystems is going to be something that is going to be more the norm than the aberration. And I think 4.0 helps us solve some of those things by connecting what we're trying to do for the customer, to the consumer, and then ultimately delivering a better product.
Okay, very good. Brian, what's your opinion on it?
Well, I like Industry 4.0 from a kind of a conceptual academic, point of view. I think it's right on. I think where people really struggle, though, is it talks about the destination and it doesn't go into the path enough. And there's a million people out there trying to talk about, their little part of the path that then ends, and some other little path over there that ends. And, everyone has a part of the problem. And Industry 4.0 is a big, big shift, if you really take it on holistically. So I think, the path is what's important. How do you do it in an integrated workflow? And where Industry 4.0 may not go enough is at the meta level. If it's all about digitization of production, what about digitization of the production of that production system? And that's what I call automating automation. And if you go back again to that analogy of what we formed our company on, is trying to take the principles from software industry, which gained its principles from manufacturing. So it's coming around full circle now. It's just software has taken these concepts further. What they've really figured out is how to automate everything, and that the benefits are more than you would expect if you just look at one project. And what it really is doing is allowing you to innovate faster. And the net in the software industry is the company that innovates faster is always the company that wins.
Yeah.
So I think our focus has always been in this industry on how do I control cost and how do I control quality. And the one thing we've always given up on was how do I innovate better than my competitor? What is it I'm doing that my competitor can't or won't do? And there hasn't been enough thought about that. And that's what companies like Apple and SpaceX and so on have done, is they've really put that other innovation first so that they could get a price premium and so on, instead of just trying to win on quality and on cost. And the funny thing the software industry has shown us is that when you automate things the right way, not in a custom way where you do manual automation, where you do automation of the production, but you're manually producing that automation, right? That manual automation is expensive and slow and one-off. And when you automate automation, the software industry, you end up with Netflix and Facebook changing their websites, their production product, over 1,000 times a day, and increasing quality and reducing the cost of every single innovation change. So the three variables of cost, quality, and innovation, you can have all three if you do things the right way. And I think Industry 4.0 tells you the necessary platform you have to have, but it doesn't tell you the path. And I think there's a really practical way to get started. And I think other people have tried to do IoT has kind of been all or nothing, or they've done it entirely too small. And there's a happy path in the middle, and we'd love to help people with that.
That's excellent. That's it. And let me just ask in closing then, as we look forward, you know, we're talking about the factory of the future, the evolution, what have you. You know, what does your crystal ball tell you? What is is there a desired end state? Is this the elimination of all manual tasks ultimately, or just the minimization thereof? And what tools do you still need to accomplish this? Mike?
I mean, Eric, I don't know that the goal is to, automate, everyone out of the factory. I think that we want to automate as many processes that really aren't creating value, for sure.
Mhm.
I mean, I think that we want to accentuate where value is created. So what are we doing that is really being rewarded by the customer? So how, when Brian talked about people and dealing with variability, like we're very good at that, right? So how do we make sure our best and brightest are focused on those types of activities with customers? So whether it's, we need to innovate something for Apple. Apple's one of our clients, right? So how do we help Apple commercialize product faster? Like, in terms of, maybe it's not just the parts that we provide, maybe it's the entire process. Not that we can teach Apple how to do something necessarily, I would never have that much hubris, but more around, hey, this is the kind of thing that we're trying to do, what do you think? And again, I call it extending the infrastructure, make it extensible. So where do we need to have people along that process to ensure that where we can't automate the learning or the capability, that we're influencing the infrastructure that we're creating so it can incorporate that information and it can learn from that, and then it can move on and move further. I think that many of the tools we talked about today, but certainly AI and ML and edge capability, IoT capability, eliminating this concept of system architecture, limiting your capability, and data as the true asset, and the transaction processing being what it's supposed to be, and getting out of that, quite frankly, and really looking at, here's the functionality I need as a product designer or a product engineer to drive forward and create value. What do I need to manufacture this line most effectively in terms of the information that's necessary? And then I think it's just, to Brian's point, rethinking what we consider an ecosystem or a platform. It's not a bunch of separate activities that get integrated through an interface. It really is a purposeful architecture that enables us to innovate faster and create more value. I think Brian said it perfectly. We have not been focused enough on how do we create value in the marketplace, and how do we do it in a way where people are willing to both reward and potentially pay more, because it's that much faster. It's of that much value to them. And I think there's opportunity there, without question.
Excellent. Brian, what's your crystal ball tell you?
Yeah, crystal ball, if I take this, to the limit, you've got Industry 4.0, you automate automation, all that. What we're really talking about here is we're going to democratize manufacturing. When you really bring in all this automation, the result of that, if you think of like the software industry, is that you can do very small runs. You can highly customize things because the cost of making a change and deploying that change out can really be a push of a button in CAD. So you can imagine designing something, and it's kind of like printing a Word doc. You didn't have to figure out how to put all the lines and pixels down on the paper. That all got assembled for you, turned into triangles and laid down, right? So the same thing, if you take this to its limit, the trend is that you're going to be able to do very small, highly customized runs of things at high quality at very low cost, because your labor costs, and you can produce them anywhere locally. And so what I use that, I say that's democratization. And put another way, if you look at the introduction of the ATM machine, automated teller machines in the banking industry, there are more bank tellers, human bank tellers today than there were before the invention of the ATM machine. And one of the things is when you make something cheap and high quality, people consume more of it. And I think what we're talking about is being able to make high quality, just the right production amounts, low volumes, and so on, very local. You are democratizing not only what can get produced, but who can produce it and where. And so I think there is going to be effect on the labor pool. I think a few people will get hurt by this, but I think it just like the teller example, those tellers now are not just cashing your check for you. They're selling investments of stocks and bonds, and they're doing all sorts of other things that bank professionals didn't do before. And I think that's what the transformation in here is that humans are creative. We have desires, and if we can automate the production and democratize it, bring the cost down, scale it down, so that anybody can do it, I think we're going to see the manufacturing industry increase. And that's happened in every industry. When you improve quality, decrease cost, it allows for innovation.
Yeah, that's very good. Thank you very much. That's, it's funny, you took me, I was actually with Bank of America when we first rolled out the Versatel machines back in the day. And I'll tell you, I made more on-call servicing those than I did working during the day because nobody knew how to use them, right? Every time that pager went off, it was $50 for me. Yes.
And now people self-service. And
Right.
imagine a manufacturing world where the customers can self-service, and they don't have to have 9 months of a system integrator coming in and bleeding them dry, and then every change order after that, where they can start to take over more of their destiny.
Yeah. Excellent. Excellent. Gentlemen, we've come to the end of the hour. I want to thank you both. This has been a very interesting and very informative discussion. And I think you've given the audience a lot to think about, and some pearls of wisdom were certainly shared there. So Mike and Brian, thank you both for your time, for your candor here today. We appreciate it. For the audience out there, we have one more of these scheduled on December 1st or 2nd, I believe it is, where we'll have the last of the conversation in this particular series. So again, to my guests today, thank you, gentlemen, both for your time. And I wish you, moving forward now, happy holidays moving into the season that we do.
Likewise.
Thanks, Eric. Yeah,
Thanks,
thank
Eric.
you.
Thanks, Brian.